Welcome everybody. Thanks for coming to my session today. My name is Justin Grote. I'm going to be showing you the many ways to run PowerShell in Azure. First of all, thanks very much to our sponsors. Without them, this doesn't happen and make this the event that it is. I'm so great to have this community. All these sponsors have always been great support of the environment and just happy that they get us here. Also, thanks to my company, Ally Digital, for sponsoring my travel and making sure I could be here. We're a multinational MSP. Our sort of elevator pitch is that we sort of help turn the IT infrastructure that you have into a utility. You don't do your own water, you don't do your own electricity. More and more, why would you need to do the nuts and bolts of your own IT? Focus on your core competency, let us handle the rest. And we do basically it all. So if you're interested, check us out. So today I'm going to be talking about Azure. And Azure is a big place, if you haven't noticed. So big that this is the last infographic that they published before they canned the team or something, because they don't make them anymore. You'll see it still says Azure ID in this thing. Azure Active Directory, excuse me. But sort of the thing is that there's a lot of places to do things, but that also means that there's a lot of opportunities. And a lot of times we kind of sometimes get a little pigeonholed into when we're using PowerShell, what we can do, what we're used to, what the documentation tells us we can do, what sort of everybody has examples for. And the thing about the cloud platforms and having all these things, you have all these opportunities with much less risk. You don't have to go buy a $50,000 server, hope it works, and if it doesn't, well, now your boss is really mad at you. You just spin something up, try it out. Maybe it's game-changing, maybe it's garbage, but either way, you can just throw it away and then decide to invest in that if it really helps you out. So in that spirit, we're going to go through a whole bunch of different Azure services that are places that you may want to consider PowerShell, and they're in that same way, maybe running PowerShells in ways that you maybe are not traditionally used to. This landscape gets even bigger. There's this site called, has anyone ever been to AzureCharts.com? If you haven't seen it, check it out. This is made by a solution architect at Microsoft. It is amazing. So this is a dynamic site that has all this information. You can hover any of those and get news on the latest things. It's got a whole news feed, ways to break down, ways to sort it by category. AzureCharts.com. Check it out. It's amazing. So we're going to be going through a few of these services. There's a whole bunch of stuff here. Some stuff like Cloud Shell is a no-brainer. Some stuff like virtual machines, obviously. But maybe there's some other areas, like maybe you never really thought about containers potentially for PowerShell, but maybe why not? So we'll be going through a bunch of those things. So as a result, we're going to be moving through a lot of stuff. We're going to be covering a lot of technologies. I'm going to be showing off a lot of neat stuff, but I'm not going to spend a whole lot of time of it up front. So there's going to be a few rules to this journey you're going to be taking with me. Rule number one, don't panic. We're going to be looking at a lot. And if you don't understand it, if you don't know what this is, if you don't even know what the word I said means, don't worry about it. Just be along for the ride. We're going to just vibe code on yourself, vibe, present, watch, I guess. Rule number two, hang on to those questions. So this is going to be a two-part presentation. The first half, we're going to go on this little journey. And I just ask if you have a question or you see something or something you want to know, write it down, put it in your notebook, tap it down on your tappy-tappy computer, whatever, but just hang on to the questions while we go through this first part. Because the second part, we're going to take like 45 minutes of that second half of this to just do nothing but questions. So I'm hoping you just kind of just focus on it, see what's going on, write down things you're thinking of. Maybe I'll answer them as I go. Otherwise, we'll do them and we'll just start some conversations. And that's sort of the plan here. And then the final rule is just try to free your mind here, is we are going through a lot of stuff here, and you're going to see PowerShell maybe in places you never thought about. But don't be stuck into the rigid of just like PowerShell running in a scheduled task on my computer or whatever. Start trying to think about ways that PowerShell can maybe run in lots of places, lots of things, and ways that might be able to help your company. And use that to generate questions so that my second half isn't really boring and me just telling more stories. And that's it for slides. So here we go. So in Azure, we have all kinds of services, and this is my little dev tenant that's got a few people in it, it's got a few resources, and we'll get to that in a minute, but we're just going to start with a repository. So in this repository, which is out on GitHub, and we'll link into the show notes, I will link into the repository, but basically this is sort of a repository with some kind of basic information that you can have here. And it all starts with this one script here, this main.ps1. So this main.ps1 is a single script, and we're going to go through what this script does, but in short, what this script does is two very simple things. It adds a tag to an Azure resource group, and it creates a Microsoft Graph entry user. That's all this script does. But to get to that point, as some of you may have found, Sometimes that's really difficult because you got to first get your authentication. You got to use the right modules. How do you authenticate? What do you do? What the heck is a service principal? What are these managed identity things I made? Can I even use them? Are they worth anything? And then how do I do it in Azure Automation? How do I do it in Azure Functions? How do I do it in all these places? Just getting to the point of doing what you want to do can sometimes be really painful and really frustrating in these things. Once you get there, it's great, but sometimes it's a journey. So this script is written in such a way to try to ease that journey as much as possible, using a few neat little techniques. So starting out, like any good script, everything that is an input to this script is in a parameter block. So anything that could change or is important, we don't do variables inside and look for them. We have them as parameters. And these parameters have intelligent defaults. So if we start, I assume that's okay to read. I'll hide the sidebar here. So for example, one thing we're going to need is a name for our invocation. And this will become clear later why we're doing this. But this simply gives us a name for this thing that we're doing. So in this case, by default, if you don't know this operator, this is new in 7. This just simply means if something's not provided or it doesn't exist, basically if it's null, then use this value instead. It's a default. It's an easy way to specify a default. So in this case, if I specify a name by the parameter, great, I'll use that. If I don't give anything, I'm going to look for an environment variable called source name in wherever I'm running. And if that's specified, I'm going to use that. If that's not specified, then finally I'm just going to use this default, which is PowerShell. Same thing here. If I specify a message, great. Otherwise, look for an environment variable. Otherwise, our default is just hello from. We're going to act against a resource group. So our default is we have this many ways to PowerShell in Azure. This is just a resource group in Azure. It's nothing fancy. If we want to use a client ID and client secret, that's an option here. Spoiler alert, we're not going to use this a single time, this whole presentation. And then some other things, if I want to specify my subscription, just some stuff to kind of make this easier so that not all this stuff has to be specified every time I do it. I don't have to forget it. Cut down on the human error. So what the script does, sort of a starting thing for me, is I always like to add error action preference stop at the beginning. Default behavior of PowerShell is that when you write error or you have errors, the script keeps going. And my general feeling is like, I want it to be it keeps going unless you tell it you want to stop. And I like to do it the other ways. I want to stop unless I tell it to keep going. And so that's usually the first line I put in every script, is that if there's an error, I want it to basically, all errors be treated like terminating errors unless I try catch them and want to use them as non-terminating errors. I'm also doing a thing for error view for detailed view, just for a reason that'll be clear here a little bit later. So one thing that we want to do is, one thing that can be helpful is getting telemetry on your script and where it's running, no matter where it runs. So I've made a module, sort of, a bootstrap script that will allow you to take any PowerShell script and get application insights telemetry on it. Where it runs, how it runs, its time, the script block, etc. Again, don't worry about that. If you don't know that makes any sense, don't worry about it. Just roll with me here. So that's where this basically bootstraps this trace AI command by basically loading it from a GitHub gist, but using an easy URL, so I don't have to remember the whole giant GitHub thing, and then brings it into my environment. So now I have this trace AI command. And so that lets me do that. And so when I do this, this sends it the telemetry and gives it a name, using that name that I had up front, so that if I run it in different environments, I can see which environment it came from. And so I can see, maybe compare in different ways this script runs. So then once I have that, the first thing I'm going to do is that if I've specified dash verbose, or conversely, basically verbose is anything but silently continue, which is the default, then I also want to gather a bunch of information about my environment. Because one place, like an Azure function, maybe you don't know how many CPUs are in there. Maybe you don't know how much memory are. Maybe you don't know what special variables are in there that's messing up your script. I mean, how many times have you written a GitHub action that works just fine on my machine, but then you go to publish it and it fails? And it's because there's something different about the GitHub action than your local environment. Well, it helps to know what those things are. So these are easy ways to just gather that information, try to get some information about the memory, gather all the environment variables, gather all the PowerShell variables, gather all the pre-installed modules before I even do anything, because maybe there's a conflict there that I didn't know about. Just basically a lot of really easy ways to just get a bunch of information and then dump it out, so that if I do have a problem, I have all this debug information, because I might not be able to intrinsically set breakpoints and do debug in a particular location. So just a handy little way to get some of that information. A real quick thing that if I just don't even want to, if I just want that top output, or I just want to, this is kind of like a what if in a way, just a quick way to do what if, but it's hard to specify what if in some of these scenarios, so this is just a way to do that. So then that's sort of all the preliminary of our script in terms of just making sure our environment's okay. So now we're at the main part of the script. So one thing that's probably pretty common that you may have run into is that when you go to deploy in certain areas, every way kind of has their own way of doing dependency management for PowerShell, how you handle your modules. If you're not just deploying one script. And in this case, I need Microsoft Graph and I need Azure AD. And so I need the AZ module. So I need those two modules. I need a way to get them. So whereas I can just use all the various ways, in Azure Automation, you have to go through a pretty painful process of uploading and verifying modules, which takes forever. Sometimes they're built in, sometimes they're not. If it's a server somewhere, I have to figure out a way to get that installed to that. So instead, I'm just going to use a module that I wrote called ModuleFast, which again, I'm just going to bootstrap it, because this way I don't have to rely on PS Resource Git to take its time to go get ModuleFast to start it. This is just a way to really quickly get ModuleFast, like within usually like less than a second. And then what ModuleFast is basically a really quick way to install modules in a declarative way. Kind of like if you've been doing DevOps stuff, you've been going to the Bicep and Terraform, we've been talking about like declarative and writing things in a way that you just say what you want and the software figures it out for you. ModuleFast is written in that spirit. So all I'm telling you is that I need AZ resources greater than or equal to 7.9. And the only reason I need AZ resources, no other AZ part of the module, is because I'm just adding a tag to a resource group. So the commands that I need are in there. No point downloading the whole giant AZ module when all I need is that. I need Microsoft Graph users above this, and I also need directory management in order to create the users and do that work. So what ModuleFast will do is it will just very quickly find out these modules and their dependencies, fetch them and install them. And it'll usually do this part in like less than 3 seconds. So even though it's in the runtime of my script, it'll take care of it. And it's also declarative and idempotent, all these fancy words you've probably heard all week in our DevOpsy world, that if the modules already exist, it'll be like, okay, they're there. I don't need to download it. And then what we're going to do is we're just going to go ahead and import them. Because I know I'm going to use these 3 modules, I'm just going to go ahead and import them before they're used. And the only reason I do this is because if you've noticed, whenever you import a module, if you have a verbose on, it shows you all the commands being imported. And that just junks up your telemetry. And since I'm sending all this to a place that I want to analyze, I'm 99% sure those logs are never going to be my problem. So I'm just proactively importing them and suppressing the verbose output. Because I know I'm going to use them anyways, I might as well load them now and then get to that part of the script later. So, all right, now we're in actual meat. Scaffolding's out of the way. So we're going to just connect to the Azure ARM API, and we just got a little things here where basically, if it's a service principal, use a service principal. Otherwise, assume it's a managed identity. Talk about managed identities if you don't know what those are. I'll talk about those in a little bit. So we do that. We do our connect. We do a little fancy. This is what I call the holy trinity of output debugging. Is different environments handle output differently. Functions handles it different than automation and other things. This is an easy way to take what you're typically used to seeing at the console and getting it in a string so that when it's written to verbose, it's what you're used to seeing in the console. Again, consistency, making sure that things work the same in every environment. Not elegant, by far, it's not elegant, but it's consistent. Sometimes that's more important. And then we do our connect. We do our magical little splatting thing where I had a starter splat here, and then I got some conditional parameters, and now when I run my thing, this just runs it. If you've never seen splatting, this is just like saying connect AZ account dash identity dash account ID. It's all just done sort of a little more programmatically and looks nicer, easier to work with. Splatting's great. Check it out if you've never done it before. Okay, then we're connected to Azure. And then we're ready to create the tag. So again, we want this stuff to be idempotent. If we go to put in a tag, we just want to be able to tell it what tag we want. And if existing tags are there, don't disturb them. That's typically called like an upsert, like update or insert. If the tag's already there, replace it. Otherwise, insert it and don't affect the other tags. And there's just a little bit of fancy logic here to make that happen. And then finally, here's our final action to create the tag in that resource group. Do a little reporting. That's great. And then move on to the next thing that we want to do, which is create a user. So we do the same kind of connect, do the connect, decide how we want to connect based on how the parameters were specified, and then go ahead and get our default domains, because we need that to build a user. All users in Graph need, for some reason, like they need a mail ad nickname, which is probably just a relic from old Active Directory days when they do the sync and everything. But in short, just got to get some of that info, make the name unique, do all that. If you've ever done basic Graph, this probably looks really familiar. This is probably like the first thing anyone ever really does in Graph as a test. And so, but again, we got all nicely defined. We have we do all the work of defining what our command's going to do so that when we actually get to it, our command, where it happens, is very simple and straightforward. I'll just kind of zoom in there if you can't see it there, but you just got that user params as a splat on the command. And so all that you saw is all in a big try-catch block. And so if anything goes wrong, then what we're going to do is we're going to use this fantastic get error command in PowerShell 7. Thanks, Steve Lee, who wrote this. That will take a command, and it's sort of like, if you're used to like concise view, detailed view, this is word vomit view. This tells you everything about that exception you could possibly need for the most part in a really, really detailed format. So rather than just get an error when something fails in Azure Functions that, a null pointer was found with no context or anything, I get a wall of red, but it's a wall of red that has the stack trace, it has what the exception was, if there was an inner exception, all the properties, so that when I go to troubleshoot that, I probably don't as much have to reproduce it locally. I can see it's like, oh, okay, it failed exactly at this point, and maybe I can look at it and fix it without having to, deploy and test and hope I can figure out where the problem is. And then finally, you have this nice finally block, which runs no matter what. So even if an error happens, an error doesn't happen, this is just a way to ensure that something runs no matter what happened above in the try-catch. So when I do that, I just have a simple message to let me know the script finished. Track how much CPU usage was used, so I can maybe start benchmarking my thing, maybe getting it faster, because some of these things are billed on like time, like CPU per second. So saving a second may, if you run this thing 20 million times a month, could save you, $10,000. Like it's just sometimes it helps to have that information. Sometimes it doesn't matter. And then just the memory usage as well, how much memory the script used. Because in some environments, they're designed for microservices and stuff, and so they can be very constrained. And so sometimes we want to know if our script, we had something in our script that just bloated up our memory, we'll know, oh man, if this goes above this threshold, it's going to crash in this environment. So I need to figure out what that problem was. All right, so that is our simple script to add a tag and add a user. But the scaffolding becomes important because it makes it resilient. And what we talk about in Azure DevOps is making things consistent, and not just Azure DevOps, but just DevOps in general, is by making things consistent, resilient, idempotent, makes them reusable, it makes them portable, and it increases your value. It makes you take the time that you take to work on this script, you're not taking time making it work for this next environment, making it work for this next environment. Hopefully, it'll just port with maybe some minor tweaks. All right. So let's go ahead and see if we can get this script to run. So as you saw, the script uses a managed identity. And so I'm just here on my local computer. This computer is not Azure AD, this demo environment is not Azure AD joined. It doesn't have a Azure Arc to it, anything. It's just a computer. It's just sitting here. But I am logged in. If I do a get AZ context, I am logged in to my MVP account, which I call MVP on steroids, because I get a nice little big old grant thanks to Microsoft to do all kinds of fun stuff. And so I'm already logged in. If you would have done Connect AZ account, whatever, et cetera. But as you saw, my script is not set up for interactive login. It's set up for doing, non-interactive work. So how can I tell my script that I, want to use a managed identity? Like, how can I test the managed identity locally if I don't have a managed identity on my machine? Well, the good news is that the way that managed identity is implemented makes it very hackable, for lack of a better term. And this is not in a bad way. It is not insecure by any means, but just the nature of what the credential is makes it so it's very easy to proxy in a way. So there's a term that we always have with like multi-factor authentication. An easy way to categorize different kinds of multi-factor authentication is what they are. So one is, what you know. That's a password. Something that you know is a way to say something, that how to attest that you are what you are. I know something nobody else knows, and you know I know that. There's another thing that is called something that you have. So instead of that, maybe you have a key, maybe you have a certificate, maybe you have a fingerprint. A fingerprint's a little wishy-washy because it's half what you have, half what you are. But so there's all those options. But then there's a final one that's always called what you are. And so something about me is an attestation. Like you might know me as Justin Grote just because you see my face and my eyes and whatever. It's like, oh, that's Justin, So a managed identity is kind of that what you are. A managed identity is sort of a fancy way of generating a certificate, and the way that it attests who you are is where you are, is that if you are a virtual machine, and we've established that you're that virtual machine, then we just say, as long as you are in that virtual machine, we trust you to do things that we give rights to that virtual machine. And we don't care who you are, we don't care, we know your actions are taken like that as a service account. And that doesn't just have to extend to virtual machines, that can extend a good amount of places. It's all certificate magic mumbo jumbo in the background, which we can talk about later. But that's the general concept of a managed identity. What it matters for you is you don't have to rotate passwords, you don't have to rotate secrets, you don't have to rotate certificates. That's all handled for you. It's super easy to use, and very conveniently, it's also probably the most secure way of doing authentication. So managed identities are basically win-win over all the other options. Anybody who's used the other options, they're kind of painful, they have issues. This looks like it works just like a password. But managed identities, for the most part, there's almost no scenario where there's another option better than managed identities if you have managed identities available. So for our examples, everything's going to use managed identities. Managed identities is spread through Azure to the point that you can use them in so many places. Places might surprise you, which we'll get to. So how do I do this locally, though? It's like I don't have this. So as I said, I can do this thing. I wrote a managed identity emulator. It's actually more of a managed identity proxy. So this is just a thing, again, goes to a Git, goes to a gist, don't worry about it, downloads a thing. And what this does is this starts up on my local machine this is all PowerShell. It starts up a little web server, and that web server listens for the token requests from the computer when it does a managed identity request. And then what it does is, based on that request, uses the AZ module and just literally like get AZ access token to get the token for what the thing requested for managed identity. Gets that token, passes it back, and just pretends, okay, yeah, here's your managed identity token. So the application has no idea, because there is no authentication in the managed identity part. Because it is what you are, because we're on the local host, we don't need to check the local host SSL certificate that it is what we're talking to. So it just implicitly assumes that if you're on the machine, then that's okay. So we're able to basically sort of man in the middle of that in a way, in a good way. Again, this all sounds scary and like, oh, managed identity is insecure. It's not. It all has to do with the fact that this is all based on context. So it doesn't matter because of the context. And so now that I have that running, it's just sitting there listening, and now I can run my script. And this failed on the Wi-Fi, but I think I got it fixed this time. So we'll go and run that. There it is, because I did verbose, specifying all that stuff. Here it is doing those things, doing that connection. And it actually, because I ran this a second ago, the token was still cached, so you didn't see it go to MSI because it still had it. But what should have happened is that over here you would have seen that request come in and go through and make the request for the managed identity and come through. But because I already had this cached, I might be able to do, I won't be able to do a disconnect thing. Yeah, forget it. So in short, because I had already run this before, it was pre-cached, but what you would have seen is that it would have grabbed that managed identity and brought it in. So, but what I just did, real quick, you saw how fast that script ran. That script took like, what, 2 seconds? And module fast ran. Module fast found what modules are on the system, said, all right, good, this looks good. And then we connected to Azure with that managed identity, as you can see here, created that tag, then connected to Graph, and then created that user. So if we go to here, and we go to our resource group, we now have a tag. And that tag is, because I said -name lappytoppy, it said hello from Miniways lappytoppy. Great. And if we go to our users list, we've got Miniways lappytoppy user. So that was an example of just having that script and having all that scaffolding, being able to run on my computer, and because I had the credentials ready to go with managed identity, it just worked. Now that's an example of a tag, that's an example of a user, but this is all the scaffolding you need to do everything in ARM and everything in Microsoft Graph. So now think about what you can now do, what you can automate, what you can do with everything that's in Graph, Intune, anything that you can hit with Graph, users, groups, distribution groups, Azure, building containers, building servers, checking servers, deploying applications, deploying Kubernetes things. Anything you can do in ARM and you can now do in PowerShell. Because if it's in the ARM and it's in the Graph, you got it there. You have all the scaffolding to do it in a secure way that's totally auditable. You go and look at all the changes. They're tied right to that managed identity. That managed identity is secure and rotated. Congratulations, you have this environment that you now have this playground that you can automate all the things that annoy you or that you're doing manually or your team's doing, etc. But that's just on my local computer, and I just did that interactively. I don't want to have a human have to do that work. So what are the options that we have in PowerShell? Well, now we start getting into some of these services that we have. So if I go back to my code here, I have in here a whole bunch of various deploys. Who has been to any of the, either knows about Bicep, went to the Bicep boot camps, went to the Bicep, basically saw anything talked about Bicep today, this week? Okay, great. So if you don't know what bicep is, if you've heard of Terraform, any of that kind of stuff, as we're talking about this whole thing about doing declarative code, talking about declaring things and doing it in a way that just saying what you want and letting the system handle it, let the system handle the how, and you just tell it the what. Bicep is Microsoft's way of doing that. Technically, it's Azure Resource Manager underneath with a bunch of ugly JSON you should never look at, but just think of it, bicep is just a really nice, friendly way to interact with that thing. It's really good, it's really cool. Alex was here, who was the project manager for it, great guy. I met him in the GitHub issues when they first started Bicep, telling him that Bicep was a mistake, and we had a whole big argument on it, and we've been friends ever since. So over here, one of the ways we can deploy is with Azure Automation. So here I have that same script, but you'll see this little arrow here. That's called a symbolic link, as you can see there. This is something that you can do in Git and things, where you can basically make a shortcut to a script, because the way that this automation works is that it needs the script in the folder. But I don't want to copy and paste the script all the time and maybe make mistakes and have errors. So instead, I just create a link to it that basically fools the program, saying, this is just a file. But really what's happening is it's secretly in the background going to my original file. So all I got to do is make changes in my source file, and they go there. And for the most part, for both Windows and Linux, Git will preserve these. So if you check in a symbolic link, Git treats it as a symbolic link. When it restores it, it will restore it as a symbolic link. So these are things that don't just have to be local to your system. You can actually have them as part of your repository, your Git repository, whether you use GitHub or anything else. There are some caveats to what I just said, but again, don't worry about it. You're along for the ride. We're having a good time. Write down a question if you want to know those caveats. So that's, again, as you see, it's the exact same script. And then we have a bicep file here. So bicep files are pretty straightforward. And this one I did not fix up for the error thing, so that's okay. So bicep files here are generally used for Azure. And so we have these new things called Azure Verified Modules, which are sort of batteries included, Microsoft supported modules that can build things much simpler with much less declaration. So typically to build an Azure Automation account, I got to create a base account, I got to create a runbook, it's like this much stuff. But Microsoft makes these modules that have all that stuff inside them and give you a much easier, user-friendly version of that. It's sort of like the Entra module versus like the graph modules. Like the graph module is like all the nuts and bolts, and then the Entra module is like a nice front end on it to extract away a lot of the unnecessary complexity to you. So here I'm creating just an automation account. As you can see, it's pretty straightforward. I can just give it a name, give it a location, and I'm giving it a system-assigned managed identity. So by doing that, now this automation is an independent unit in my system. You treat it sort of like a user. Without going into a ton of detail, there's a thing called service principals in Azure, which are basically glorified service accounts. Is that if you use your service accounts on premise, you're used to that of like a user that has a user password, but we say we only use this for services. This is like a structured way of doing the same thing. It's still basically a user with a password, but that password can be one of many things. It can be a client secret, which is just a fancy way of saying a password with restrictions. Because a client secret is, the restrictions is that we make you rotate it occasionally, and we don't let you choose what the password is. So we generate it for you. That's what a client secret is. But in the end, it's still just a password, and it's something you have to save somewhere to use, and something that could potentially be compromised, especially if you accidentally check it into a GitHub repository, and you got somebody like me who has a script watching every new commit in every GitHub, looking with a regex for something that looks like a secret to be able to use it and immediately compromise your system. The streets are littered with the blood of poor AWS developers who accidentally checked in their public bucket keys 10 years ago. Most people are better about that now, but it still happens all the time. So yeah, that's the thing where we just have to say, don't do that, but mistakes happen. I've done it. I've accidentally done it. I did it as a test. I didn't realize my thing wasn't in git ignore. I thought it was in git ignore, and then I committed it. I was like, oh, crap, get it out of there, rotate. But the nice thing is what if we don't have to care? Again, what if we, instead of treating the credential being something I have or know that I have to give you, what if it's just something that you can look at me and say, oh, you're running in this virtual machine, and that's virtual machines in a secure location or whatever, then, okay, just by looking at you, I know who you are. And so I'll handle all that stuff. I'll generate a certificate for you, I'll rotate it, I'll do all that kind of stuff, and then I will get you your access key. You have like a little broker there. Well, now we don't care. Now you'll see there's no passwords, codes, anything in this because we're using managed identities. That's the power of managed identities, is they're both good for you because you can't screw up, and they're good for the company because it's still an individual thing. It's a unit of measurement. Everything happens under that account. That account gets discrete permissions. You give it permissions to a particular resource group. You can give it least privilege. Security guys love this stuff until you show them my little hack thing, and then they get nervous. But don't show them that. Use that for your development, but don't show them that. And so you have this, so that all gives you the idea of like, so now we have this thing and we have now attached a managed identity to it. There's this thing called user-assigned managed identities. Don't worry about that. We'll talk about that later if you want to. But typically, if you can, use a system-assigned managed identity because that basically, it's bound to the life cycle of your Azure resource. So again, in DevOps, if you're cattling that pets or whatever the politically correct term is these days, and you're spinning these things up and killing them down, spinning up and killing them down, if you have that credential tied to it and are provisioning it in the life cycle of that thing, then it's not some password saved on a file share somewhere that some other developer goes, oh, that has the permissions, I'll use that for that. And now you've got some shadow IT thing going on that suddenly this credential is being used elsewhere. It's like, why is the Concur accounting app creating users? Like wasn't their scope. And then you find out so-and-so did this. It's like, well, it was easy and it was there. And like your guys' approval process takes forever. So I just did that. You can eliminate all that with the exception of somebody like running their software in your virtual machine. But again, at least you know it was there. Yeah. How dare I say something so specific and accurate? It's very rude of me. So now that we have that, now we have a thing and we have a managed identity, but now we actually have to give it rights because by default it doesn't have anything. If anybody used Azure Automation in the old days, it did this wonderfully secure thing of when you created an Azure Automation account, by default the account that it used got contributor rights to the entire subscription. So it'd be easy. Because we didn't want PowerShell people like clicking run and getting an access denied thing. We can't have that. It's got to be easy. Yeah, that got changed once stuff got serious. So you'll see those. If you ever go on Azure Automation accounts, that was called a run as account, and you'll see it's like big, fat, deprecated. Like even in the menu, it says deprecated. So the moral here is don't use run as accounts anymore if you can get away with it. And there's almost 0.01% reasons why you would still use a run as account. So what we want to do is that I want to be able to create tags. I don't want to just give contributor to my role because I don't want this script to go haywire and delete the whole service account. So I want to give it the least privilege that it needs to do its job. That's best for everybody. It prevents me from screwing up. It makes the security guys happy, and it makes sure that the scope is such that it can't go outside the boxes of what it needs to do. It makes everybody happy, makes everything safe, reduces mistakes, reduces downtime. Always a good thing to do if you can. And luckily, Azure is extremely good at this. Some programs, not so much. They give you like admin, read-only. Those are your choices. But Azure is very good at being very extremely granular about how you do that. But the nice thing is that we don't have to click ops this. We can actually define it in Bicep, where we can say, here's our role assignment, here's the details. Again, using all this conditional stuff, which you saw before. Those concepts translate to Bicep. And then we get that thing. And then a new thing that's in Bicep, this is in preview, is now you can use Microsoft Graph inside of Bicep. So it used to be the Azure role was easy. Assigning the graph role through infrastructure as code, a nightmare. It was a whole thing, and then it was like, what credential who watches the watchers? What credential do you use to give the credential? Blah, blah, blah. Now it's really easy. Now we can simply define our things. This is a bunch of magic mumbo jumbo to get the roles that I want, but I want user read write all because I want to create a user, domain read all so I can check that user's there, and directory read all for reasons I'm not going to go into. Dumb reasons. So we have that, we get all that, and then we assign that account to our permission. So you deploy this, it deploys it, creates an automation account, and here is our automation account that has all that stuff in it. So we go to our runbooks, we got a mini-ways here, we'll fire this guy up, start the job, go ahead and run it, we'll go ahead and name it. This one we'll just call Azure Automation, because that's where it's running from. Again, there's that name parameter, just like you saw in the script, and this is just how we're going to name it so all the telemetry knows what it is. And we'll go ahead and run that. While that's running, we'll also go to this one, which is Miniways AA Hybrid. So one of the neat things you can do with Azure Automation is Azure Automation generally runs in a tiny little container, a really tiny, very painful to work in container, especially for PowerShell. But you can use it, you can buff that up if you need to. You can use a virtual machine in Azure if you need to do a bigger project, or you can use something that's joined via Azure Arc. So this Miniways AA Hybrid is actually joined to a machine in this hybrid worker groups. This guy I named Tiny Cloud, which hopefully will come up. There we go. So in this group is a hybrid worker named TinyCloud. This guy right here. So he's attached via Azure Arc, and what he's running, he's actually a virtual machine in AWS. It's an EC2 instance. So it's not even in Azure. It's not even close. Like, it's way over in EC2. So there's no way that we would be able to use a managed identity to do this because it's way over there, right? Wrong. Azure Arc can provision managed identities to anything that you can do with Azure Arc. So if it's a server, if it's a Linux server or a Windows server, and it has 443 access out to Azure, you can run Azure workloads in there and manipulate Azure from that machine. Excellent use case. You have a computer that's in your environment that's joined to your domain and has access to Active Directory. You want to do something about some special attribute that Entra ID Sync doesn't handle, some special company thing that you have. An example of this side was with some distribution list building based on special custom exchange attributes. So you can read, on that machine, you can read that information using your on-site credentials and your service account, and then using that managed identity, write it to Graph or Azure or create a thing or whatever. So now you have this great bridge, and you can do it all in PowerShell. And you can author it here and have it managed and runbooked and lifecycled, all that stuff. So we're going to go ahead and run that one too. Go back to that AA hybrid. Start it. Run it. We'll call this one hello from AA hybrid TinyCloud. This time I'm just going to select the hybrid worker, run it on there, and then that'll go. And it'll run. And I think the other one's probably done by now. So if we go back to our resource group, there's our new tag there. Hello, Vinny Waves from Azure Automation. And if we go to our users, it's there. Now notice, I didn't have to my script because Module Fast handles the dependencies, and it does it really quickly. And we handle all the sort of inputs and outputs in there. It's the same script running on my laptop, running in Azure Automation being pushed to some AWS EC2 Linux server somewhere, whatever. And that thing has a managed identity on it. It's totally secure. All the changes that are made, if you go into the graph changelog, you'll see that this user was created by that managed identity, and you can trace it right to that Azure account. Fully audible, all that good stuff, fully secure, and it's created. Well, that's the laptop, but here's the Azure Automation, and then once the hybrid gets done, if that server didn't crash on me, that's not a good sign that it's not refreshing. Let's find out. Books. Did you work? It's still running. Okay. It's pulling. It's got to do some extra stuff because of the way that it's pulling down. And basically, hybrid runbook workers sometimes take a little time to schedule. So still working though. We're good. It's not crashed, so that's good. But when it does get done, just to show this, it has the input, it has those outputs that we normally showed. It's got the logs, any exceptions that occurred. Okay, so another place that we can run these, that's how we would do in Azure Automation. We have this other thing called Azure Functions, which some of you may have heard of, several of you probably heard of. And so we have these things called Azure Functions, which is a place to run PowerShell in this really cool, like lightweight microservices way. The problem with Azure Functions sometimes, though, is that the functions environment by default is very, very small. You get like half a core and 512 meg. That's great if you're writing like a little lightweight Go app, if you're writing a thing. But if you want to write a script that needs to use Graph and PowerShell and import these hundreds of megabytes of things, and also live within the 5-minute consumption of the default Azure Functions, that can be tricky. So usually your option is Azure Functions Premium, which is expensive. Well, there's a new option in between. It's now called Flex Consumption. So this is GA. This is not preview anymore. And it works just fine for PowerShell. So the way Flex Consumption works is it behind the scenes will take your script, package it into this special little functions container with the whole functions runtime, and then run it in Azure container instances. This is how it all works behind the scene, but you don't need to know any of this. It just handles it all. And because it can do that, you get much bigger runners. You can get runners that are 2 gig, 2 CPU and 4 gig of memory, or 4 CPU and 8 gig of memory. That's a lot more room to work with, a lot more to do. And so if we go back to our script here, deployment, we'll go to deployment option number 2. Again, Azure Functions is a little more complicated. You get all this scaffolding. It's sort of a PaaS for Azure Functions in the sense that it gives you all this easy stuff for bindings and stuff to make it so you don't have to know the details. But the key here again is the infrastructure. And here's our main deployment. And there's our thing. There's our function app. Our function app as part of the deployment gets a managed identity. It's built in for Flex apps because they need it for deployment. Only this time, rather than repeat all that stuff about doing the graph stuff, I put it into its own separate little module here. And so all that stuff that you saw before of like giving it the tag contributor and all that kind of stuff, I made a little bicep module that's kind of like a PowerShell function that summarizes things, has inputs and outputs. And so now I don't have to write all that stuff again. All I have to say is I want it to have those permissions. So here I am with those permissions, and then apply it to the managed identity ID, function app outputs, but give that managed identity the rights that it needs. So I do that, publish, do my whole function publish, do all that kind of stuff, and now I have this main function that again is my script. And I can test and run this, and we'll go ahead and run it. We'll do a post, and we'll just do we'll do again that name header for the post, and we'll say, we'll call this one Azure Functions, and go ahead and run that. And then we'll just go ahead and let that run. And so what this is doing is Azure Functions is built more for event-driven stuff where you like hit it with a website or trigger it based on something that happens in a queue or those kind of things, and then have it work. And okay, good, it was pretty quick this time. So got the thing started up, again, did the whole module fast thing, minimized all the things that it's loading, and it's done. So because we have a much larger environment, it took way less time. Like it only took there a couple seconds to do that whole process. And if we go again back to our thing here, we should, for our tags, hello from Azure Functions. And also hello from hybrid Amazon EC2 thing running over there. Not even in our data center, not even attached to Azure, but just has, because it's been Azure archified, we now see it. It's part of our control plane. We can do updates to it. Imagine servers in your data center, some blade somewhere, physical, virtual, in VMware, doesn't matter. If it's a Windows or Linux virtual machine and you can install the Azure Arc agent to it, then you can treat it like it's in Azure. Pretty awesome, right? And that includes running scripts, doing Azure Automation, all that good stuff. All right, so these are sort of a lot of the different places that we can run Azure functions that we know about. But there's also Docker. Docker is a way of taking pretty much any kind of code and putting it in a little box that allows us to run that anywhere. So very recently, if you haven't seen the news, about 3 weeks ago, the Microsoft team announced that they're no longer publishing Docker containers, and instead they're using the .NET containers that they provide. So then specifically the .NET SDK containers, the one that is now the official PowerShell image. So that has PowerShell in it. There's a couple issues with that, obviously. One is that it's an SDK image, so it's like 3 gigs in size, and it's got this whole surface area and all kinds of potential CVEs and security issues, et cetera, that if your goal is to just run PowerShell code as an application or to do any kind of deployments, it's not a great environment for that. So hopefully something down the way there will be more options in this regard, but in the meantime, I saw this, and so I built some new custom container images. So one of the nice things about the .NET team is, in addition to the SDK image, they provide this thing called a chiseled image. And so the chiseled image is a version of a container that doesn't even have an operating system in it. Doesn't even really have any package managers or anything. It's literally just the bare minimum stuff to run .NET. And so you can take the versions of PowerShell that are written to not be self-sustaining, but they're called FX-dependent builds, which basically means is that it's the parts of PowerShell that'll work as long as the .NET runtime is there, so it doesn't have all the extra crap to make it standalone. You can merge those together, and you get this very lightweight, very powerful container that is less than 140 megabytes, high performance, and has a minimal security area. And so, like, here's an example of using that container. If you have Docker on your computer, you can run this command right now. And it will go out, fetch it from the public repository, run that script. Here's a case where it runs cowsay and just grabs some random quote from the internet. But you'll see at the top there, that's just a PowerShell script. Any PowerShell script you want to put in that block, it'll run it. So that's an easy way to run scripts. Another thing we can do is we can take that and put it in a Docker file, and very simply, from that image, copy in my script, and then tell it to run my script. So these 3 lines, now you can build a Docker container that runs a PowerShell application for anything. You can have it run PowerShell Universal, you can have it run a pod web server, you can have it do a task and shut down, and now congratulations, you are now part of the microservices revolution. You can load this into Kubernetes, you can build things. You are just as good as anybody writing Go or writing C# or writing TypeScript and talking about how fancy their DevOps orchestration, everything is like that. You can do it too. There's nothing in PowerShell that you can't do that they can do. It's just a matter of how persistent and persnickety you are. Like you want to do AI, ML stuff, you can do it in PowerShell. It's going to take you a lot longer because there's not pre-written libraries for it like there is in Python. But you can do it. If you can do it in .NET, you can do it. So once you build that, then, okay, well, let's use this to run our script. So we have this container here. And so we have these Azure container instances. And so again, we'll go ahead and build it. This is going to start looking really redundant. A bicep file, real simple container image. And again, there's that system-assigned identity again, using a managed identity. Don't have to worry about giving it a secret. Don't have to worry about storing it. Key vault, don't care. Don't even need to start one. Key vault doesn't matter. Don't need it. And all I do is I give it my image and the environment variables and make sure that it loads that image. And we're good because I built that container, that 3-line container, and then published my own container. And so this is now the mini-ways PowerShell container. So you can go online, run this script, and as long as you have rights, as long as you do the whole managed identity thing, you can run my script and create a tag in Azure and create a user in your environment. Real simple. Give it some size, that kind of thing. Give it those permissions again. Got that module, so it's real simple and brief, and I deduplicate, and I don't have to worry about mistakes there. And that's built. So then we come back here, we look at our resource group again here. You run that deployment and it shows up in here. In my case, I made it here as, I don't remember. I think it's the ACI, yeah. So here's a container instance. Container instances is just a really easy way in Azure to start a Docker container. No orchestration, no Kubernetes magic, none of that crap. Just run a container and let me know when it's done. Really cheap, really effective, extremely cheap, like 0.00001 cent gigabyte per second. So like you can run these things all day long and get charged $5. So I have my container here. Again, it just boots that thing, and I'm just going to go ahead and start it. And again, it's got the managed identity, it's got the tag contributor, it's got all that because I deployed that in Bicep, but it's unique to this device. It's going to be in all the audit logs that's specifically from the Azure container instance, and you can even follow it back to that Azure container instance. So every resource that got created, you can go to that user and know it came from Azure Container Instance. You can go to that user, know it came from that hybrid runbook worker that's over here. Very discrete, very nice credentials, and also very importantly, not tied to a person. How many scripts do you run that's like tied to a person? That person leaves, somebody else comes in, that person had some kind of weird permissions that nobody documented, and the script no longer works. And now you're spending 3 days trying to figure out what permissions that guy had. Or you just yellow it and go global admin and just be like, good. Nobody's ever done that, right? That's never happens, especially when the CEO's breathing down your neck. Yeah. So because the identity is tied to the life cycle of the application, then it doesn't matter if people come and go. It's there, and the permissions are tied to that. That's why we use service accounts, but this is a service account on steroids because you don't have to deal with the recycling, any of that kind of stuff. And when the thing dies, service account goes away with it. Don't have to worry about deprovisioning. So I ran that thing. If I go here under monitoring, I should have under my containers here. Okay. So here you'll see in the logs here, it ran the script, took about 20 seconds, container was killed, terminated with exit code 0. Great, probably worked. Let's take a look. Let's refresh our tags. And there is from Azure Container Instances. So same script, didn't change it, exact same script, but now this time I built in a container instance, deployed it with Bicep, and now it's running, doing the exact same work, just in a different place. Maybe there's an advantage to that. Container instances, like I said, are cheap, they're fast, they're self-contained, so you can bundle all your modules with them and not worry about the environment changing. You don't have to deal with all the crap with Azure Automation of like loading the modules and waiting half an hour for it to finally compile. Maybe you can be more agile. Maybe you can start building containers that are dependent on other containers. Maybe you can build one that doesn't just start and stop. Maybe you can build one that's a web server or a PowerShell Universal that has a service desk app that gives people easy ways to reset passwords using those discrete credentials. Again, possibilities. If you can do it in PowerShell, you can do it in .NET, you can do it, and this is just another place you can run it. So let's take it a little bit further than that. There's Kubernetes. Kubernetes is a wonderful thing. It's extremely complicated. And you can do this where you can take that container, put it in a Helm chart, do all that kind of stuff. I'd happily do that demo, but I only have 90 minutes. I don't have 6 hours to go through all that. So luckily, there's this wonderful thing that Microsoft has made called Azure Container Apps. Azure Container Apps is sort of a PaaS to extract away all that stuff, handle it for you. If you just build your containers, you say how you want them to run, you say what you want their life cycles to be, it's kind of like you do with Kubernetes, but you don't even build a Kubernetes cluster. You just run your container app and everything else gets handled. If it needs more servers, it handles the Kubernetes, it handles the scale out, it handles the compute. You don't see any of it. And it's pretty great. So there's a specific kind of Azure Container App called a Container App Job that is suited for things that aren't event-driven or anything like that. It's just something that you just want to run, go, and stop. What do we know that we typically run that just runs, goes, and stops? PowerShell scripts. Sounds like a great place to do PowerShell scripts. Should we try it? Sure. So with ACA, you just need a container. And so we go again back, and again, as I keep going here, this is all just in Bicep. So you can just run this thing, don't even need to think about it, change my script, and deploy, redeploy, and it's there. So I got my thing. In this case, I'm going to use a user-assigned identity, and the reason for this being is because of the way Kubernetes works. All these containers are starting and stopping and going and all that kind of thing. That in this case, we need a shared credential for all those things to be able to use. So a user-assigned identity is a one-to-many managed identity. It's like a managed identity, but rather than being tied to the lifecycle of a resource, it's standalone. So you can, there's reasons you want to do this. Maybe you want a consistent thing where you have a thing that needs to do like 3 different things or run from 3 different places, and you want a consistent place for that credential. It's useful for that. Or in this case, we don't want to have to create a managed identity and generate a thing and do all that work every time we spin up a container, because we might be spinning up thousands of them a second if we get to the right amount of scale. So instead, we're going to use a scoped credential for those so they can reuse it, but it's still scoped to basically that container app. It's not explicitly scoped. This is another one of those things where you have to like use Azure policy and all that kind of stuff to prevent other people from trying to use this managed identity. But it's very easy to do in Azure, and so you can effectively secure that so that it's only for the things that need to use it. In order to do that, we run it, we do the deploy, blah, 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 do that, give it up Azure PowerShell version, say what we want a timeout for, blah, 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 feed it our script, and now it's in Azure Container Apps. We go here to our container app job, and again, Bicep deploy, new AZ deployment, however you want to do it, however you like to deploy your stuff, deploy it to the landing zones, all that stuff, however you want to do it. Just there's your Bicep, do it. So now we have it here, and we're going to go ahead and run it. And so this will spin up the job and do its whole thing and bring it to a close at the end. But again, that was it. Like I literally deployed the thing, told it my script, and it run, and now I'm a Kubernetes expert. Because that all uses Kubernetes, ACA all uses Kubernetes underneath, handles all the scheduling, handles all the stuff, scales it to 0, all that stuff. Azure Container Apps are amazing. And they're also all built on consumption. So I don't have to pay for the running compute instances in my ACI, in my cluster if they're not in use. As soon as this thing stops, it stops being charged. And again, 0.00016 CPU per GB is how it's built. So we got that guy running, and again, we'll have things for monitoring. And this is really annoying, like having to go to all these different places to check and remember, okay, the logs are here, the logs are there, this one's in this format, this one's in that format. Boy, it'd be really nice if we had a standard way to look at all these. Anyway, there it is running, and it has successfully completed, looks good. Go back to here again, broken record time, check our tags, refresh, and the ACA jobs. There it is right there. We haven't checked in our users lately. Go to our users. And here's our users being created in all these different locations. And again, I do this as a simple example, but you could have your entire user deployment pipeline just in a script in a container and just give it some parameters and boom, done. So we got that going, and that's a container app. And so I showed the hybrid already. So we have all those things. So that's all great, but what if we want to actually deploy things? One thing a lot of people constantly complain about Bicep is like, well, what if I want to do a thing? Or what if I want to do things that it only does the infrastructure part? Like, what if I want to do the data part? Like, it doesn't deploy my script. It doesn't do the ACA. It doesn't like do any of the data plane stuff. It doesn't put stuff in my storage account. It only creates the storage account. I still have to do all that crap. Well, there's this wonderful thing called deployment scripts. So this is an Azure resource that the way that this works is in a Bicep pipeline, you treat it like a resource, just like you were deploying anything else, and it being depended on and all that kind of stuff. But in the background, it uses that, remember when we showed the Azure container instances? It, in the background, spins up a storage account for you, spins up an Azure container instance, and runs your script in a container with a managed identity as part of your Bicep deployment. So now, again, if you can write it in PowerShell, you can deploy it with Bicep and deploy it in a standard way using that credentials, using the permissions of the credentials so that they can only deploy in a certain resource group, et cetera. So typically you would use that to do deployments. What are we currently doing? We're deploying a user and we're adding a tag to a resource group. Adding a tag to a resource group, yeah, we could do that in Bicep, but what if we had some special requirement? What if we had to go to ServiceNow and pull from our inventory of applications and add tags for that thing? You can't do that with Bicep, but you can do that in PowerShell. So we'll take, again, our same script here, our ACA jobs, deployment script, And so I showed that. There it all deploys. And then we come over here. And in this case, I actually have to run it. And this part I'm probably going to screw up. So let's find out. New AZ resource. Do I have it there? Close enough. And so you can do bicep deploy. You can do that. PowerShell has native support for deploying bicep now. Like it in the background, it literally just does a bicep deploy. But PowerShell does have native in the AZ module. You can deploy bicep just fine. So we're going to go to our 7 deployment scripts, and then get to that main bicep again. This gets really slow because the autocompleter is not the greatest. Come on, stop trying to compile my thing. All right. Well, just like in DevOps, fail fast. You're done. You had your chance. Deployment script. Main.bicep. Pretty sure that's it. Anyways, PowerShell deploy. See if I got it. Did I get lucky? Maybe. Fingers crossed. Did I lose my token? No, I'm good. Okay. Maybe it'll grab that manager's identity. Okay, I did verbose, so it's doing it. So here you can see in the background, it's converting it with bicep, and it's actually converting it to that ARM, that special magic language JSON thing you should never look at again in your life if you can help it. And so now it's just basically creating a deployment, and now it's doing it. So if I go here to my resource groups, get back to the resource group. If I go over here for deployments, there is, or should be, is that done already? No, that can't be done. Wi-Fi might not be happy with it. We'll see. But anyways, had this been going here, you'll see here for the miniways deploy script, you'll see here's the deployment, and it's doing it, and here's that deployment script item. And here's where it actually ran the script, executed that script, loaded it in, built a little special Azure Container Instance, and ran it the same way like I did in Azure Container Instances, but as part of the build pipeline in Bicep. And hopefully if it works, if otherwise, if you go here, you'll see on the tags, if it works, you'll see in here from deployment, the one that I put there for deployment. So that's a bunch of different ways. I didn't go through everything. Like there's Cloud Shell, there's all kinds of esoteric places. So if you want to nerd snipe me and be like, well, actually you didn't do this part, that's why I called it the many ways of PowerShell, not all the ways of PowerShell in Azure. Okay, so we've got that, but our script's been running all these places, and we got this script, and so great, it's running all these places, but like how do I, if I'm running this same script in all these places, I have to go all these places to make sure it's still working. It'd be nice if I had a way to just monitor it centrally. Well, remember back when we first started the script, there was that trace AI command that wrapped everything? Everywhere that this script runs, it's been reporting back to Azure Application Insights, which is sort of the backbone of a lot of services like Azure Monitor and such. So it's been reporting to this Application Insight. So if I go here, and I come down here under monitoring, you'll see here there's a bunch of different requests, a few different requests. Oh, like here, these seem kind of correlated timestamp to where I've been in my presentation. And if I come down here to application map, you can see here on the conference Wi-Fi, hopefully you'll see here, there we go. So you can see here there's a few of these things, these instances. So I can go here to this main script, and you can see all the places that it ran and how long it took at each place it ran. And if I go to the individual ones, I got all my performance statistics, and I even have this thing called transaction search. Or if I want to look at the transactions, there's all the PowerShell output to the console output of every command, when it ran, all the telemetry. And if you go to an individual result here, and I got all this analysis, like I can see, imagine this is a script running on somebody's desktop, or one that you have deployed to a bunch of places where it's running thousands of times a day. And what if you could just go here and find out, oh, Frank, it's messing up on Frank's computer because I'm seeing exceptions come in, or set up an alert, hey, this script is getting issues in that computer over there. You can do that because it's reporting the telemetry to Application Insights. And hopefully eventually I'll have this working with Open Telemetry. Right now it only works with Application Insights. But what you have now is like you have observability, you have scalability, you have the ability to find, if we go back in my history, you can see all the times I screwed up in this script where I forgot to deploy the managed instance, or I did that. But you can do that analysis on your work of where are people messing up, and then adjust your script to make it better. Congratulations, you're now a site reliability engineer, and you should ask for a raise. And so if we go into the failures of these, like here's some times when it failed. I don't know, let's go here. This guy, this one didn't work right. I've got my terminating error, I've got all my detail. But you can see here, it's got the whole detail of the script. When it ran, what happened, how long it took, and how long in the script till it failed, and then all the detail of the exception. And again, remember early on when I did that thing where I wrapped the exception to dump all the text? By default, you get a really unhelpful error message in here. But now, I get all that show error output, and I can find out exactly what went wrong, where the script failed. I can see, hey, dummy, you forgot to put an MSI on it. And so there you go. But without even having to, I don't have to get into the thing, I don't have to debug it, I don't have to put in write hosts in it to try to figure out what's going on. I get the telemetry through the script, wherever the script runs. Didn't change the script once. As you saw, I didn't touch the script to make it work anywhere here. And you can go to the repo that you'll see. It's the same script in every single place that I just ran today. So that is a journey of places where you can go and deploy scripts, find out where things go, and all the different places that you can run it in a consistent way using the same credentials, using the same level of access, and open yourself up to all kinds of opportunities beyond just being the guy who deploys users. Yeah, we deployed a user. Yeah, we deployed a tag. But with PowerShell, you can do anything in Azure, anything in Graph, anything you can do in PowerShell, anything you can connect to in PowerShell. If you need to save credentials, that managed identity can tie to a key vault. And that key vault has your old style, old and busted ServiceNow credentials. That's just an API key. But it's stored, it's saved, it's encrypted, and you still never see it. You don't put it in your code. More possibilities, more ways to do these things, more ways to expand where PowerShell happens, where it works, running in containers, on-site, off-site, anywhere. The possibilities with PowerShell are not just simply that thing that's in box that we used to do Exchange with. You can make anything in PowerShell that you can make in any other language. It's a Turing-complete language. So I encourage you to go out, think about where you can do these things, and see the ways that these can be deployed in great, secure, powerful ways using the language that we all love. So thank you very much. I appreciate having you here. All right, so we will go ahead now and we will bounce to questions. So if you had any questions, if you wrote anything down, if there was anything that I showed that you want to know more about, take a look at, that kind of thing. Want me to say again, explain a managed identity again? Happy to do it. We're here for the rest of the session for a half hour to do any of that. So, yes? So the question was, with all my demos, I was using managed identities, and since they're system-assigned managed identities, were those all the same managed identity, or were they different managed identities, and how did any of that work? So the answer is they were all individual credentials. It's effectively as I created SA-container apps, SA-automation, and more specifically, SA-mini-ways automation, SA-mini-ways ACI. So they all are individual discrete service accounts. So how you would do you have experience with making app registrations and that kind of thing? Okay, so the old school way that you would do this is you would build an app, and then you would build an app registration, and then you would give it the graph scopes using the GUI, right? And then you would go over to Azure Resource Manager, and then you go into IAM, and then you go add, and then you'd add that same service account, that app principal, and then you'd add it and you'd give it the roles that you want it to have, and congratulations, you're done 2 hours later. So this process is basically doing all of that, but in infrastructure as code, defined in a file. So if you wanted to give it a new permission, you got to go in, you got to find it, you got to hope you don't make a mistake, you got to hope you don't actually remove the thing, you hope you don't fat finger the right name. In the infrastructure as code way, you got that bicep file. Okay, our script now needs to change group, so we need to add group.read.all. You just go into that bicep file, add group.read.all, make a pull request to the company. The smart guy me goes, why do you need group read all? It's like, well, I also included the script where I show that. I code review, all right, looks good. I merge you in. The pipeline deploys that back out. It's been updated, and now your script is running with that new managed identity. But if you wanted to do that, again, you'd have to remember that, or I have to remember to do that, and then I forget, and then you're complaining, hey, my group read permissions don't work, and I'm on vacation, and I come back a week later. So what happens here is that with the managed identities, they're tied to the actual application. So it's like that. It literally works the same way under the hood as a service principal. It's just the life cycle of it is automatically managed. So rather than you doing all that stuff manually, and more importantly, you creating it and deleting it, it gets created and deleted with the resource. So if I were to delete that automation account, it will automatically delete the managed identity without you doing anything. And that credential no longer exists in your environment. And then as far as the credentials go, what happens underneath the hood is the way that the client uses it, so the way that my script gets the managed identity credential is it calls a special endpoint, a localhost :5039, or there's an environment variable that most environments put in there that tell it like, hey, here's where you get a credential. And then it does OAuth. If you've done OAuth, if you've done get AZ token, any of that kind of stuff, it just does an OAuth request, and it just basically is able to say, it doesn't put any kind of username, password, secret, or anything in there. It just does, by virtue of what it is, it's an app running on this server, and because it's localhost, only that thing can hit that thing for the most part. Again, slightly exploitable thing there, but again, you have to have admin rights. It's not a big deal. It's not a big deal. It sounds really insecure, but it's not. It is actually very well thought out, and it's a really great balance of security to usability. Anyways, it makes a call to that REST endpoint where it just says, give me a token. I want a token for Microsoft Graph, and I want scopes, user read all. If I don't specify scopes, just give me whatever's on the thing, and that's where you specify .default. Otherwise, if let's say you have rights to all of Graph, but for your specific script, or the particular thing that you're doing, you only want rights to user read all, and then you do that part, and then you can re-authenticate again and get different scopes. So even within the scopes that you're given, you can personally make them more granular at runtime. Like Graph, OAuth, all that stuff. As much as we hate scopes, as annoying as they are, as much of a pain in the ass as that you wish would just work, there's really a lot of thought that went behind them, and it can allow you to have these very granular, very secure applications. And so once you do that, it gets the token, but what happens is that there's a little agent running on the system, like the laptop where you're at, and what it does is that it's actually secretly going back to Azure and rotating a certificate credential. So a managed identity is basically just a app principal when you do the certificate authentication rather than a client secret. That's what a managed identity is, like under the hood. It's just that, but Azure is handling rotating that certificate like every day, kind of a deal. So that it rotates the certificate so that if I revoke that thing, that certificate's no longer valid. So you try to ask for your token again, it'll say, nope, it'll on the back end, it'll say that, and it's all managed consistently. So you'll see it if you go into Graph, if you go into the sign-in logs, you'll see it just like you would any other service principal, although there is a special tab for managed identities now. There didn't used to be. They used to be way harder to find, but now Microsoft's been working really hard at making it really obvious what managed identities are doing. Yeah. Right, so the question was, when the bicep file runs, it's running as that managed identity, how do you scope down that part? So there's a correction there. When you run a bicep, like when I did that new AZ deployment, it doesn't run under the managed identity. The bicep deployment runs under you because you're the one doing it, so it's based on your permissions. So I'm owner in this dev tenant, but let's say I only had rights to like one resource group. If I tried to run the bicep deploy to another resource group, it won't work because it's using my delegated rights. There's a concept in Graph of delegated versus application permissions. Delegated means use my permissions. Like you're going to do, like I give you permission. It's like you telling an intern, here's my credit card, go get a coffee. You're giving him permission to do it using my credentials. And if he screws up, they're going to blame me because it's my credentials. Whereas an application thing is I am giving you a credit line that's in your name. You go and do it, but it's not dependent on me. And so in general, you use delegated credentials for interactive type things where you're doing something on behalf of a user. If you're using the Azure portal is just one giant app that uses delegated credentials. When you make changes, if you can watch it in the background and watch it just hit the ARM API the same way the PowerShell one does, but it's just using delegated for yours. When you do AZ, unless you specify a managed identity or anything and you're just logging in using OAuth, then it's doing things on behalf of you. All this stuff is consistent. It all uses the same technology. Yes, although that being said, so the question was like if you want to set up an environment where like the bicep is run automatically, like how do you set up credentials for that? Basically, like is that kind of the question?
I understand that. I know how to set up permissions. I was saying is that the case?
But the example that I did is where it was run as me, but you can run a bicep file as a managed identity or as a service principal, et cetera. And the cool example that I did not have time for this demo because it's only 90 minutes only, is there's this thing called OIDC. And so the way that I showed you how like I was running the script in Azure Arc, there's a way that you can set it up so your GitHub action pipelines and your Azure DevOps pipelines have a managed identity. So like you run bicep deploy in your GitHub action, and because you have basically set up this federated credential that basically tells Azure, this very specific GitHub action in this very specific environment, you get really granular with it. If it's running over there, then it's allowed to request a token for this managed identity. And that's how it gets its permissions to do its graph stuff, do its that kind of stuff. So your effective thing would be is like in that example where I say make the pull request and it automatically deploys. The automatic deploys part would be Azure pipelines or GitHub actions starting up, requesting that OIDC credential. But there's no passwords, there's no secrets stored in the code, there's no secrets stored in Key Vault that it's got to fetch. It's just because it is that GitHub action, and we trust. I look at your face and I go, okay, you are that. Come on in, sir. Right this way, Mr. Reeves. Yeah, and that was always the really tough thing. So the thing was like it was unclear about who was running, and that was always the really difficult thing before this preview of the Microsoft Graph support in Bicep. Is that in order to do the Bicep thing, because it couldn't run as the deployed credential, you then had to deploy a credential to then do the graph stuff using that deployed. It was just a nightmare. And now it's just much cleaner, much simpler. I think I don't have much time to go into is deployment stacks, which you may have seen in some of the Bicep tutorials or such. This Microsoft Graph extension does not support deployment stacks yet. That's all I can say. But deployment stacks are a really great thing to do because when you deploy something, deployments are nice because they show you what was deployed, but there's no lifecycle management. Whereas if you're used to like Terraform and stuff, you can do Terraform build, and then you can do Terraform destroy, and it'll destroy what it created. Deployment stacks are that in Azure now, is that if you use a deployment stack, and it's the same Bicep file, you don't change anything, you just do new Azure resource, new Azure deployment stack, I don't remember. New AZ resource group deployment stack. So you just take the same command and you just change it to stack, and it works the same way, but it does it into a deployment stack. And what that does is that gives you a full life cycle so that you have this object that you can see. It could be deploying across subscriptions, across, all the way across, and deploying users and doing all that stuff. And then rather than you having to remember to go clean all that stuff up or having a script that remembers to find that, you just delete the stack, and the stack takes care of deleting all that stuff for you. Really cool stuff. But it does not work with the graph thing. If I wasn't doing the graph thing as part of this, I absolutely would have done this deployment as a deployment stack. So it does not support it yet. So the question is, can you make an Azure Automation account that does delegated? Yes, but don't do it. Yes, but it's dumb. Like, there's no point. I guess that's rude of me. I'm sorry. Do you have a particular scenario in mind? Okay. So the thing about Azure Automation is that it uses run as accounts. Basically, what I was going to say is what you would have to do is you would have to do like the device code login thing, where your Azure Automation script would stop, make you go and do an interactive login to then be able to give it the delegated credential so that it could then fetch the token and do it. So is it possible? Yes. Most things are possible. It would be a nightmare. The better use of that is Azure Functions. So Azure Functions can be event-driven. And when you go to an Azure function to say bring up a service page or bring up PowerShell Universal or bring up whatever, to bring up a form or even just to trigger a thing, then the first thing you can do in Azure Functions is make you log in or use your browser credentials that are already there. And so once you do that, now it has your token and it can work it delegated. But all delegated things require an interactive login is sort of the short. Again, for all intents and purposes, if you want to use delegated credentials, you have to have the user interactively log in. If you're doing non-interactive, you pretty much are stuck with application credentials. Always exceptions, but 99.9% of the time, and the reasons you would do the others are stupid, don't do them, Any other question? Yeah. Okay, so the question was, if I'm currently using a service principal and I'm already being a good boy and my vendor isn't an idiot who only supports client secrets and I'm allowed to use a certificate, why would I want to use managed identities? Is that basically it? Okay, I paraphrase because it's a leading question from me. But so here's my thing to you. How often do you rotate that certificate?
By default, every year.
And do you do it manually? How long does it take you?
Too long.
Have you ever forgotten to do it and broken your app?
We have monitoring in place, so no.
If you use a managed identity, all that's handled for you.
I know.
And also, where do you store that certificate? In a secret vault? Okay, how do you get to that secret vault?
Yeah, well, it's installed in the system.
Yeah.
Again,
My whole point being is that you now have this thing you have to manage.
Yeah.
And managed identity does away with all that. It's still a certificate credential. You never see it. You don't have to know about it. It all is handled in the background for you. And it's automatically rotated, all that stuff. All you need to know is that my thing runs here. It has its rights.
Yeah, I like it. I mean, which is why it leads to the question, like, feels like spinning up that listener to intercept that call.
So that's a development like implementations thing. So even though I did that, you could write your, like, you notice how I had the service principal thing there? Like, you can write your script so that it just uses your permissions. But the reason I do that is because I want to, and this doesn't use those same permissions. So I could still test it locally and not work there because I'm running it under me. I'm basically proxying, what that thing does, here, I'll just bring it up. I basically did this to make it easier because one of the annoying things about managed identities is testing. Now, if you were in a company, what I would say is that you take your workstation, you join it to Azure Arc, and you can give your laptop a managed identity, and then you don't have to worry about it. It's easy. But if you're in an environment where you're just testing random stuff, this is just an easy thing that I've had for demos, and especially I made it before the Azure Arc was a thing. LA/MSIEMU. All right, no, I don't want the raw. I just want the. Well, I got the gist at least, so I can do that. Come on. Okay, yeah. All right, so this is the code for what happens there. And so how supported is it? It's, hi, it's me, I'm the support. Like, so what it does is no different than like other things do. So what it does here literally is it just sits there, it listens on that interface, has to do all kinds of fancy base64 stuff because I'm using a raw .NET HTTP server that's built into .NET. So again, if you can do it in .NET, you can do it in PowerShell. Here's a living example of that. And so then this start listener function, it creates those special environment variables. Basically, it tells your application, hey, here's where you should get your managed identity. And this works even if there's a managed identity already on the box because it'll override what's already there. Sometimes there's a reason you want to do that. It does that, and then when the request comes in, I'm in the background just doing get AZ access token. Literally, like, I'm not like doing it fancy at all. It's like literally right here. Get AZ access token, take the expiration, take that, and then route it back to you. Here's your access token. So in the same way that you don't have to care about the certificate or any of that kind of stuff, in this way you don't have to care about like where that token came from. Like the app never like verifies that the token came from a specific managed identity. That being said, you can verify it because in the access token that you get is this thing called a JSON web token, and is default base64 encrypted. So by default, it looks like a bunch of junk. But you can decode that, and in there is information about who logged in. So in there will be who logged in. So if the app was smart, if your app was custom, you could do something where you could say like, hey, if the person who logged in isn't this managed identity, throw up a giant red flag. But the PowerShell and stuff, they don't test for that. And so most of these things don't test for that. So it gets back a token, it looks at the scopes are good, but it doesn't see that the audience says jgrote at jgrote.cloud, but you can test for that. It's just not there by default. That'll probably be more of like with the confidential computing stuff and all the crazy stuff where like a graphics card presents an SSL certificate to the app so that you can prove that it is that graphics card and not somebody trying to intercept it. I imagine something about managed identity will eventually come to that point, but it's really not a big deal. Huh? Yeah, then it breaks when they change it, yeah. Yeah. So this is basically, it's just an easy way to do testing, but you can just as easily the supported thing to do would be do Azure Arc, put a managed identity on your machine, and then test with that, and then just give that managed identity the same permissions as your prod or whatever environment. Yeah, we can always talk more about that. All right, we got 10 minutes left for anything else. If not, I'll just show some random stuff and start some more ideas. Okay, well, how about I show a little bit about how that telemetry script thing that I made works. So this came about because if you go to the PowerShell home directory, if you have a version of PowerShell since PowerShell 6, yeah, let's go Explorer. All right, so you got this is the PowerShell bits. And if you don't know .NET, basically you have your PowerShell executable here, psh.exe, and behind it this is really the real meat of it. This is just some scaffolding. And then you got all these things called assemblies. These are all the things that are in .NET, and these contain all the logic to do things. So one of the things that we love about .NET is that it's batteries included. Like if you do Node or Go or those kind of things, you get a very basic level of stuff, but then you have to go get everything else. And .NET made the decision to say, hey, how about at least for the things that like 90% of people are going to use anyways, let's just include it. We'll give them ways to take that stuff out if they don't need it, but for the most part, we'll just include it. So that makes life easy. Because PowerShell is so general purpose, it brings in a lot of this extra stuff. So one of the things that's also brought in too is, have you guys ever seen like the state of the shell and they have that graph of like how many billion PowerShell executions are happening? Have you ever wondered how they get that information? So in the PowerShell code, there's a telemetry thing, and you can opt out. Like if you're tinfoil hat, there's an environment variable you can set and it won't send it. But what'll happen is that every time it starts up, it does the same application insights like I did for my script, and it sends out and it just says like, hey, PowerShell 7.5 on this operating system doesn't have any identifying information about you, except when they made a mistake and I opened an issue. I was like, hey, you're collecting info. They're like, oops, and they fixed that. But it's just anonymous information to get information about startups. But in order to do that, you have to have some kind of code to do it. And the PowerShell team didn't want to write their own version, so they just use the Application Insights DLL, which gets provided by Azure. But if they're using the DLL, that means it has to be part of the library. So if it's part of the library, that means, that was bad completion. I cannot type for the life of me. No, application. So because it's part of the library, because it's built into PowerShell, you can get to it and you can use it. So what this script does is that the reason that it works is that you don't have to download any extra. The reason that it just worked just running the script as opposed to downloading any kind of extra C# assemblies or modules or anything is because it's all pure PowerShell. Okay, I've got to do this again. Bit.ly. Trace PS, that's what it is. And then we go to the GIST. Now, yeah, like some random bit.ly link, if you're concerned about that. The bit.ly part, maybe not the most secure, but if you did the IWR pipe this, pipe IEX, I would argue that's just as secure as having a signed script. And the reasons why are that it's an HTTPS URL, it's bound to a commit so I can't change it, it's out of my repo, so you're already trusting that it came from me because either somebody has to compromise my account to get to it, to change it, and somebody can get to my account to change it, they can change my script and re-sign it too. And it's transmitted secure end-to-end and executed. So people are like, oh, IWRing, IEXing scripts from the internet, terrible procedure, horribly insecure. I disagree in this scenario. I believe that I will easily make the argument that this is just as secure as a signed script. So here's the function, here's the work that it does. And so the way that it works is that it's able to use that special telemetry client and instantiate it in the background. So the way that Application Insights work is that you get a key from your Application Insights workspace, and then when you create the client, now you can use that client to send telemetry to it. Pretty straightforward. It's pretty simple methods, and it's all documented. I'm not going to go through it right now, but it's got like a send trace, send error, send metric. So you can do all those custom. So what I do is that when you do trace AI command and I put that script block, that just makes it ergonomic and easy to use. But when you put your code in that script block, what happens is then trace AI command will then take your script block and it will actually wrap it in a separate execution within PowerShell. Not a separate run space, but a separate execution. And what it does then is that what it can do is, again, because everything in PowerShell is an object, even that text you see on the screen, if you do write host, thanks since 5.1, don't believe Don Jones hype, since 5.1, everything comes out as an object. It comes out as an information record. It comes out as a warning record. It comes out as an error record. It comes out as an output object. But you can run PowerShell in such a way that rather than go to the console, it outputs all the .NET objects that eventually get translated to the console and gives you that nice text anyways. So I basically do that. I intercept everything that your script is doing. And then based on the content, like, is this an exception? Write it to Application Insights as an exception. And note the timestamp so that we can get a timeline and benchmarking of everything that happened in the script. And so I can intercept all of that and then just use this DLL to send it. And it's smart enough that it can like queue it and send it and flush it. It's all optimized and fast and doesn't slow down your script much, like barely. Use Jakob's profiler to prove it if you don't believe me. And so I intercept all that stuff, I do the thing, and then I pass it back to the console host. So it effectively works, it's basically like a shim. It sort of inserts itself so that everything that happens with your script, the output of it, gets through the shim, gets sent off to application insights, and then continues. So that's why I was able to just you can use it with any script. Like I can do trace AI command, throw whatever, and it'll just show up there. And then the role name and stuff is how I specify when you get the application insights, it has this whole thing for being able to divide. So you can tell it like different servers, you can tell it different runtime environments. You can have that role name and name mean anything you want. So by name, by default, I just use my invocation to get the name of the script. So that's why you saw like main.ps1, but you probably saw like there was like some weird rando ones. That's because like in container instances, I gave it to it as text file. So in the process, it generated a random name for the PS1. But because Application Insights still sees it as a PowerShell script running, it just took that name. That's why they all didn't just say miniways.ps1. But you could make it to do that. And so it's a really easy way to, that I've always felt is really lacking in PowerShell, is like we don't have a super easy way to just get telemetry on scripts. Whereas like in .NET, you have things where you can have it do auto telemetry and get that. This was my version of implementing that, but in such a way that you don't have to download everything. It's 100% PowerShell, which is a little bit of a lie because it's 100% PowerShell, which is a little bit of a lie because this is the emulator. I'm not even looking at the right thing. Because the code that I use underneath is already inside PowerShell. So if I wanted to make an open telemetry version of this, if you went to any of the great open telemetry talks, so that you can use this in anything, not just application insights, but use it in Datadog or New Relic or any of the or an ELK stack or any of the 1,000 monitoring telemetry options that there are out there. I can make a version of this to do that, but then it has to be a module you install. It's not as easy to just simply bump in and run for a test. So I'll probably get around to that someday, or maybe somebody else will write it. Or even better, I'll convince Steve to ditch the application insights and have the open telemetry stuff inside of PowerShell, which in and of itself causes a whole bunch of problems, which is why it hasn't happened yet. And if there was that, then I can just, again, reuse the native stuff. But that's how the tracing works. And again, the code here is not that complicated. Well, that's a lie. But my point just being is like here's where I run your script, and you've seen star, I don't know if you've seen this before, but basically this is me redirecting all the output to the pipeline. And then for everything that comes out the pipeline, now instead of like an error going to the error, it's now, oh, yeah, sorry. I don't have this in VS Code, my bad. Actually, I can have it in VS Code. Yeah, we'll get this. Come on, script analyzer, you can go fast. There we go. Okay, so here's all the scaffolding, get it set up, do all that stuff, blah, 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 whatever, and some environment variables and local things to track things, because it actually works if you do trace AI command, trace AI command, trace AI command, it'll nest in the application insights. So you can track portions of your code relative to everything else. Really cool stuff. I'm very proud of myself, frankly. So it does this, and then so here's that telemetry thing. And here's where now, because I'm capturing all your stuff as a debug record, a verbose record, rather than it going to the console, I can choose how I want to act on it. So this is the pass-through part. This is the part where after I've shimmed it, I'm just taking your object and then writing it back to the commandlet and having the commandlet write debug, write verbose, write information, whatever. This write AI telemetry is where the magic happens. And if I come down here to where that is, this is the part that gets ugly. But you can see if it's a verbose record, this is that client that I was talking about, and here's what I'm just doing track trace the object message. Same thing. If it's a debug record, track trace a little bit of extra info. If it's a warning record, same thing. Information record, some extra bonus info. Error records are a little more complicated because I want to get some special custom properties. And then the default is sort of basically try to JSONify the object and then send that as a trace object as an output thing. So you can see the output of the script without being at the console. Like, again, you don't even have to go to automation and try to find the thing, or container insights and try to find the place where it is. You just go consistently to the same place and you can see the output of the script. So that's how that works. All right, I believe we are at time. So again, thank you so much for coming. I hope this opens some minds, and I'll get the same QR code you've seen all week. Would be great.